guys, welcome again to this channel. Let us know more about the most common types of resistors, and one of that is the Wirewound resistor. So you see here in the drawing there is a wire called resistance wire. Normally it is made up of a material of manganese or tungsten. It is wrapped around an insulating core. The insulating core is made up of porcelain, a pressed paper, or a cement. So this is typical figure of Wirewound resistor. These resistors are commonly used for a high current application, and also with those whose accurate resistance values are needed. And you can have this device from 5 watts or more, and if you are working at surface temperature up to 400 degrees Celsius, Wirewound resistor is the best device. Now, Wirewound resistor is determined by a number of factors. These are the length of the wire. Actually, the length is directly proportional to the resistance. So also with the diameter, the diameter is inversely proportional to the resistance of the wire, because diameter involves the cross-sectional area of the wire. And the resistivity also. Resistivity is directly proportional to the resistance of the wire. So these are the three factors: the length, the diameter, and the resistivity. Okay, so the properties of a Wirewound resistor are very important. Knowing these properties, this comes in the application of the Wirewound resistor. One of that is for the high power applications, because Wirewound can dissipate significant amount of power. Okay, where dissipation levels rise above a watt or so, and you can have it also bolted to a heatsink. Some of these Wirewound resistor are also rated up to 2.5 kilowatts. So these are one of the properties of the Wirewound resistor. The other one is it has a very high tolerance. So you can use that for the system that needs a high tolerance applications. Since that we are using a resistance wire, the Wirewound resistor can be made with a great precision. Actually, some have an initial tolerances for about 0.005%. Wirewound resistor is very useful in this application, especially in measuring instruments. Another one is when the high temperature stability is needed. We have this so-called TCR, or the temperature coefficient of resistance. So the Wirewound can be designed to have a very low TCR. It means that its adaptability to the temperature is very stable. As advances in material science we have right now, or the engineering materials, they have constructed devices with the temperature coefficient of resistance for as low as 5 to 10 parts per million per degree Celsius. This is totally dependent on the metal or alloy used for the resistance wire. So another one is the stability, the long-term stability. So another key feature of Wirewound resistor is that it has a long-term stability. All resistors has this changing value with time, but the Wirewound ones, it changes very little only. It's about to 15 to 50 parts per million per year, and are often achieved. This kind of changes is achieved because of the stable materials that was used for the construction of the device of the Wirewound resistor. Another one is the ability to absorb pulses. So unlike some of the forms of resistors, this device are able to withstand high voltage pulses. Well, they have this so-called high thermal mass and resiliency of the wire, which means that they are capable of absorbing energy levels above their average ratings for short periods without damage or a change in resistance. And the other one is, if you are doing with a system where customized requirements are needed, the Wirewound resistor is the best because it can be manufactured as relatively easy to make customized devices, specifically to a resistance required by the customer for a particular requirement in project. Then it has also property of a low noise. For application requiring low noise, you can have the Wirewound resistor device. Materials are being placed for this device so that the lowest current noise can be achieved. Now for the major categories for a Wirewound resistor, it is categorized into two. So the precision resistors is all about the testing instruments. For example, the multimeters and measuring bridges, the calibration equipment, and the AF attenuators, and many others. So Wirewound resistor is the best one device for this precision instruments, for testing instrument, for it requires only is very small current and voltage, and power application is not an issue. Now for the power resistors, it is where the power dissipation issue is required. So you can have Wirewound resistors for a range of up to 1 kilowatt to 2.5 kilowatt. We use silicon resin encapsulation for those whose system operates on approximately 300 degrees Celsius, and also for those who operate on approximately 400 degrees Celsius, we can use the vitreous enamel coating in your Wirewound resistor. And for the highest power level, the aluminum case is used. These are the categories of Wirewound resistor: the precision resistor and the power resistor. Now for the construction of the Wirewound resistor, one piece of wire would have to serve as the path for electrical current to flow from one end of the resistor to the other. So therefore, to create a resistor with a small ohm or resistance value, you use a thicker or shorter wire as the path between the two electrical leads. This applies the principle of resistance, which is equal to the resistivity times the length all over the cross-sectional area. Okay, so but we have a problem in our construction where inductance and capacitance are built up. So we have to reduce the inductance in a wires. So this can happen only in manner of winding. So we have this so-called Bifilar Winding. So this kind of winding is, there are two separate wires that run together. So you see here in this figure, there are two wires, and this can be joined at the far end. The far end, it is joined. So So the concept is that by running these two wires in this way, so the current, you'll notice the arrow, the current will run in this direction, and the other one will run in the opposite direction. So therefore, if this current flows from this direction, applying the right hand rule where the direction of the fields is there, it may be clockwise surrounding the conductor, and the other one will be counterclockwise. So there will be a cancellation of the fields. In this way, the inductance are minimized. But as two wires are run in close proximity, there is an unwanted capacitance increases. So there is another way of winding aside from bifilar winding. This is what we call the Ayrton-Perry winding, which is taken from the name of the person who invented and discovered this kind of winding. There are wires that in the resistor coil, and you split this into two, one half being wound in one direction and the other half in the reverse direction, as you see here. So this is in one direction. The other half here is the other direction. So in this manner, the wires are arranged so that the current flows in opposing direction. So same as the bifilar. Thereby, it reduces inductance, and also capacitance is minimized since that the wires doesn't run alongside in the same way. So there's only a very minimal increase of capacitance. So Ayrton-Perry winding is a good winding. Now for the carbon composition resistor, this is another common type of resistor aside from the Wirewound resistor. This is the figure. It is actually divided, finely divided carbon or graphite. It is mixed with a binder. It's a powdered insulating material. Then there are two metal ends here, as you see in this figure. The leads. This is for soldering to connection to the circuit. Kind of resistor, the CCR, are available from 1/10 to 2 watts. You'll see here the figure, and it has a color bands here to indicate the rating of this resistor. Okay? For the carbon composition resistor, the main advantage is that it has a high energy pulse capability. So the carbon composition resistor can withstand to a much higher energy pulses than most other types available today, and as compared to the film types. So as a result, are sometimes used in areas where high energy pulses may be present. So you use CCR for application where high energy pulse are present. It has a high energy pulse capability, and it has a disadvantage about this stability. This kind of resistor is very unstable. So heat could also change the value when you are placing this resistor to unexposed to a higher temperature, and so when you are doing a soldering, the value could be altered by 2 to 3%, and operation at temperature of up to 70 degrees Celsius, it could alter also the value for 15% or more. So it is very unstable. The other one is the high temperature coefficient. The figure for the stability of the CCR worse than 1000 parts per million per degree Celsius. This is what you can expect of it. Has a very low degree of temperature stability. Other one is the noise. The CCR actually was very noisy because the material inside resistor is a composition of carbon, in which carbon produces noise. So therefore, other forms of resistor are vastly superior with respect to the noise factor. So these are the samples of our CCR, and thank you so much for watching this video. I hope that this video adds learning to your learning desire. Thank you so much.